Hello friends. So in the previous class we studied about the what is AP. Now here we will study about sum of n terms of an AP. N terms of an AP. Now see, let's say I have given this series. Let's say the sum denotes S and the AP is something like this: A plus D plus A plus 2D, something like this till A plus n minus 1 D. Now what is its derivation actually is, again write this as, but write in opposite order, like A plus D, like that. So here it will, what will come, A plus n minus 1 D, like that. Okay, now if you add these two, 2s is equal to, see here, if I add these two terms, like first term of both, what I am getting, 2a plus n minus 1 d. Fine. Now if I, what will be the term before that? Here it will be something like a plus n minus 2d. If I add these two terms, what I am getting, 2a plus n minus 1d again. See, here also this sum, here also this sum. So for every terms I add, I am getting the same things. So now tell me how many number of terms are there? N terms. So can I say this thing will comes n times if I add same number n times? Basically means multiplying that number with n times. This will be equal to this. So from here, what is S? N by 2, 2a plus n minus 1 d. Remember this as a result. One more result we can deduct from this is, we know this S is equal to n by 2 into 2a plus n minus 1 d. Hey, I write this only in a previous case, yeah. Okay, now can I write this as n by 2 into a plus n minus 1 d? And what is this term? Last term for our sequence. This term will be last term for our sequence. So can I write same thing as n by 2 into a plus l? So this is also a formula. So two formula for summation of series AP. Remember these two formulas. Okay, now let's see one result from this. Let's say S is this, t1 plus t2, like that till tn, and before that tn minus 1. Okay, so if I consider this part, can I say it is the sum of first n minus 1 terms, so this should be equal to s minus 1, s of n minus 1. So can I say s is equal to s of n minus 1 is equal to tn plus tn, or I can say tn is equal to sn minus sn minus 1. Remember this result, it's a very applicable result, and this result is valid not for AP, it is valid for every sequence. Okay, now one interesting thing about AP, from this we will conclude. Let's say I have given this Sn is equal to n square plus n. Now sometimes question will come, he will give you Sn and he will ask you Tn. How will you find Tn? Tn will be, can I say it will be this Sn minus 1. So look at this, I can write here n square plus n minus n minus 1 square plus n minus 1. I can write like this. Now I can write like this, n minus 1 square and this plus n minus n plus 1. This n cancel here, a square minus b square form. So it will be 2n minus 1 into 1 plus 1. So you are getting what? 2n. Now if I put n is equal to 1, I am getting what? t1, 2. And now tell me one thing, s1 means sum of one term, sum of first one terms means t1 only, and what you are getting from here, 1 plus 1, 2 only, so this is equal to t1. So this is a valid sequence. And if you carefully observe this series, this Sn is equal to n square plus n and Tn is equal to 2n, that it is an AP. How come? See, if I find T1, that is 2, T2 is what? 4, T3 is what? 6. Now what is the difference? 2, 2. So that's why it is an AP. Now look at one interesting thing. Let's say Sn is n square plus n plus 1. Now find Tn. Now Tn will be this Sn minus 1. So it will be n square plus n plus 1 minus of n minus 1 square plus n minus 1 plus 1. If you simplified it, this 1 cancel, this n cancel. So here again 2n minus 1, 2n minus 1, and it will be plus 1. So here you are getting 2n. Okay, so here if I put n is equal to 1, t1 give me 2 and s1 give me 3, but this is not possible, so it is wrong. Got it? Okay, if something is given, so this is invalid. Okay, the sequence is invalid. Okay, fine. Sometimes question comes and you have to check like this by putting these values. Okay, now one interesting thing for an AP, Sn is generally quadratic and this Tn is linear, but it is not true always. Not always. Like we see the previous example, here this is quadratic and this is linear only. Got it? But what I can say, if it's something like quadratic like this an square plus bn type, then it can represent a summation of AP. Got it? Now we understand the formula for summation of n terms of an AP and one property based on that. Now solve few questions. Let's say there is a question, I'm giving you a question. Let's say find sum of all the natural numbers which are divisible by 5 but less than 100. It's a simple basic question. So number will be something like, just see, tell me, it says divisible by 5 means 5 a natural number should be like this, 5, 10, 15, but number should be less than 100. So it will go till 95. Now tell me how many number of terms. One way is like, this is first term, this is second term, this is third term, it will be 19th term, na? 19 into 5 is equal to 95. One way is this, if you go by the basic, 95 will be 5 plus n minus 1 into 5. Common difference is what? 5 only. So from here also we will get what? N is equal to 19. Okay, now I got n is equal to 19. Now use the formula for sum. Sn will be what? N by 2 into a plus l. So what will be this? 19 by 2 into a is what? 5. L is what? 95. So it is 19 into 100 by 2, that will be 50. So it is 950. Got it? Now write one more question. Let's say sum of all 3-digit natural number which on division by 7 gives remainder 3. Now see, first of all, 3-digit number I need to find. 3-digit number, smallest number is 101, 100. If I divide it by 7, what I am getting as a remainder? 717, 30. 37 for the 20. I am getting 2 as a remainder. Remainder is 2. But I need remainder what? 3. So the term will be 101. Now here I am dividing by 7 now. For sure next term will be 108. So next term will be what? 115. Got it? Now look at the last term now. See, greatest number will be 999. If I divide this by 7, I am getting what? 7 1 the 7, 29, 7 4 the 28, 19, 7 2 the 14, 5 I am getting. But I need 3. So it should be 2 less than that. So it should be 997. Okay, now I know what is common difference. 7. I know first term and I know last term. So I need to sum first, find the value of n. This will be 101 plus n minus 1 into 7. So from here you are getting n minus 1, 7 is equal to 6, 9, 8, 96, and this will cancel 7, 7 1 the 7, 19, 7 2 the 7 8 the 56. Okay, so we are getting n is equal to 129. So now what will be the sum? As 129 will be 129 by 2 into first term plus last term. What is first term? First term will be 101, and what is the last term? 997. So 129 by 2 into what this you are getting? 891098. So wait, got it? I think it's enough for today. Thank you for watching.